Hi, my name is Joshua Fuller, and today I will be showing you how to do the 2009 Problem 1 AP problem. So let's just read this before we get into it. 1. We see a picture of a graph, and the description below says, Karen rides her bicycle along a straight road from home to school, starting at home at time t equals 0 minutes, and arriving at school at t equals 12 minutes. During the time interval 0 is less than t, which is less than 12 minutes, her velocity, vt, in miles per minute is modeled by the piecewise linear function whose graph is shown above. A. Find the acceleration of Karen's bicycle at time t equals 7.5 minutes, include units of measure. B. Using correct units, explain the meaning of the integral of 0 to 12 of the absolute value of vt dt in terms of Karen's trip. Find the value of the integral of 0 to 12, the absolute value of vt dt. Shortly after leaving home, Karen realizes she left her calculus homework at home, and she returns to get it. At what time does she turn around to go back home? Give a reason for your answer. Larry also rides his bicycle along a straight road from home to school in 12 minutes. His velocity is modeled by the function w given by wt equals pi over 15 sine of pi over 12t, where wt is in miles per minute, for 0 is less than t, which is less than 12 minutes. Who lives closer to school, Karen or Larry? Show the work that leads to your answer. Okay, let's begin with A. Find the acceleration of Karen's bicycle at time t equals 7.5 minutes. Indicate units of measure. So, 7.5 minutes is right here. Now obviously it's not marked, so we have to figure it out. Now if you remember, acceleration is the difference in velocities. It's the derivative of velocity. So we're trying to find out how much it's changing at that point. So how do we do this? Very simple. We find the value at 7, the value at 8, subtract them together, and then divide them by the distance. So the value at 7 is 0.3, the value at 8 is 0.2. We do 7 minus 8. If you reduce that, you get 0.1 over negative 1. Or if we simplify that, we get negative 0.1. Now, what is that? What does that mean? What are the units of measure? So if we go back to the original, we see that her velocity is in miles per minute. So this difference, this acceleration, is in miles per minute per minute. So this is her acceleration, or miles per minute squared. This is her acceleration. She is changing at a rate of negative 0.1 miles per minute every minute. Let's move on to B. So, well, yes, this is the answer. B. Using correct units, explain the meaning of the integral of 0 to 12 of the absolute value vt dt in terms of Karen's trip. Find the value of the integral from 0 to 12 absolute value vt dt. So we'll start with the first part. The meaning. What does this mean? Well, when we see this, 0 to 12, that's the time it took. That's this area. And the integral is the area underneath our curve, or closest to the x-axis. So the meaning, since this is a velocity, we want to take the integral of velocity. And the integral of velocity, if you remember, is the distance, how far she's traveled. And so the integral of the absolute value of velocity, which means since it's an absolute value, we're eliminating positive and negative, we're making it all positive, we're finding the total distance she has traveled. And you're like, okay, what else is there? Well, if there was no absolute value, then it would be the net change. This little part right here would weigh in, but we're not trying to find that. We are finding the total distance, how far she has ridden on her bike. If you would attach a little distance tracker on her wheel, what would it say? Since it doesn't register negative speed, it would say the absolute value of, it would say this function. So if we figure that out, we find out, and how I did this, I broke this down into triangles. This triangle has a base of 2, height of 2, and then you divide that by 2, so that equals 2. These two triangles are equivalent, so that's plus 2. Figure out this triangle, which is 3 over 2. It's 3 high, 1 across. This section right here is 3 high, and just continue going and doing that. Plus 5 over 2 plus 6. This whole block is 6. Oops. This whole block is 6. And then this last triangle here is 1. And if you add that all up, it's 18. But, and this is what tripped me up, this is not in this is not in miles, this is in tenths of a mile. So, this is tenths. So she has ridden in total distance 1.8 miles. C. Shortly after leaving home, Karen realizes she left her calculus homework at home and she returns to get it. At what time does she turn around to go back home? Give a reason for your answer. So let's break this down. She left it at home, which means she returns to get it. In order to return, you have to turn around. And when you're turning around and no longer going a forward direction, you are logically going a backwards direction, moving negatively. So the only point at which she stops going forward and goes backwards is right here, 2, because she has crossed from the positive domain up here across the x-axis into the negative. So she has turned around, and then at this point, she has crossed over again into the positive. And that is the point. So to be clear, 2 minutes is when she turned around. D. Larry. Okay, introducing a new character here. Larry also rides his bicycle along a straight road from home to school in 12 minutes. Same amount of time as Karen. His velocity is modeled by the function W, given by Wt equals pi over 15 sine pi of 12t, where Wt is in miles per minute, same as Karen. Remember, you gotta think about these things as you're reading this problem. 0 to 12 minutes, same as Karen. Who lives closer, Karen or Larry? So if we go back to this problem, we want to figure out how far Karen lives. Well, Karen, this says that she lives 1.8 miles is the total distance she traveled there. But that's not how far she is away. Remember, she turned around. So these two triangles subtract each other. They get rid of each other's influence. We can basically get rid of them because that's the point at which she went forward and then backwards. So it doesn't count towards her trip at school. It's zero sum. So if we take in the fact that she went 1.8 miles, and each of those triangles are worth 0.2 times 2. So those triangles added 0.4 miles to her trip because she had to go forwards and backwards. 1.8 subtracted by 0.4, 1.4 miles. So Karen lives 1.4 miles from school. Now we just got to figure out Larry. Now, Larry, we can't use a calculator for this problem, remember. So Larry lives the integral, because remember, if you integrate velocity, which is this function right here, you get distance, and you traveled 12 minutes, integrate from 0 to 12 of pi over 15 sine, pi over 12t. If you integrate that, you will get the total distance he traveled, the net distance he traveled from 0 to 12 minutes, which is, if you plug that into your calculator, 8/5 of a mile, or 1.6 miles. Now, 1.4 compared to 1.6, Karen lives a shorter amount of time than Larry. Lives a shorter distance from school than Larry. If you are looking for an additional problem, try 2003, number 3. It's very similar. Thank you.